Hey guys, it's me. Good morning. So far, everything seems to be going well for this evening's video for Tuesday morning. So hopefully everything will continue. All right, guys, this one a little bit different than yesterday. Today we're simplifying radicals. Okay, simplifying radicals. This might actually be easier than yesterday for some of you, so stay with me. There's 2 pages of notes front and back, but really it's very repetitive. The first part I'm going to give you a bunch of words, stuff you need to know. But then when we start doing the examples, even Owen says, oh, I don't understand all the stuff that she says at the beginning, but he gets the examples. So the examples will probably help explain all the words in the beginning. Okay, so let's get started. All right, so 11.2, simplifying radicals. All right, simplifying radicals. Okay, to simplify them. Now think about what simplifying means. Okay, you've been doing simplifying for 2 years now. All right. So if we're going to simplify radicals, this is how you do it. Step 1, write the radicand. Remember, that's that number inside the radical sign as the product. What does product mean? Multiplication of its prime factors. You're going to be multiplying prime numbers of radicand. Basically, you're going to be doing some factor trees. As soon as I say factor trees, you all should maybe moan and groan and blah, blah, blah. But some of you should, or all of you should be like, oh, yeah, factor trees. So blah, 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 you'll be doing factor trees. Okay. 2. You're going to apply the product property. To the perfect powers. Whoops, to the perfect powers. All right, if you are sitting there going, I do not remember the product property, blah, 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 it's okay. Trust me, I'm going to show you right here the example, but honestly, once I start doing the actual examples, it's all going to make sense. So if you don't remember the product property, don't sweat it. This is the product property. Again, memorizing the product property is not going to help you at all. I mean, it really isn't. But remembering how to solve these problems, the examples that I do, that's what's important. So don't freak out if you're like, what the heck is that? It's okay. It's okay. Mrs. Rogers said it is okay. Step 3, simplify the roots of the perfect powers. And then step 4, multiply the factors inside and outside the radical. Now, all of you, or most of you, are saying, what? What? So, yeah, hang with me. I'm going to show you the first example, and it's all going to start making sense, especially after the second, third, fourth, fifth, sixth, seventh example. I think I've got about 7 examples here. And they're all done very much the same way. So if you stay with me and watch this video all the way through, by the time I'm done with these examples, it's all going to start making sense. Okay? Trust me. So first example. Let's simplify 18. Square root of 18. Now, as you know, there's nothing times itself that's going to give you 18. 4 times 4 is 16. 5 times 5 is what? 25. So there's nothing that's going to give you 18. That's why, we have to simplify it. It's not a perfect square. Remember, perfect square would be something like square root of 4 is 2. Square root of 25 is 5. Square root of 9 is 3. Those are perfect squares. The stuff we're doing is not. So we have 18. Nothing times itself is going to give us 18. So we have to do the factor tree. So step 1, blah, 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 factor trees. Radicand. Write the radicand. Remember, the radicand is the number inside here. This 18 is the radicand. Write the radicand as the product of its prime factors. Basically, you're doing a factor tree. So let's say what 2 numbers gives us 18. We can say 9 times 2. 2 is prime, so we circle it. 3 times 3. We circle them. Do y'all remember this? Okay, if you have parents watching, you should be showing them how to do this because you've done this before many times. 2 years in a row you have done this with me, so I know you've done this. So then we write it out and we do smallest to greatest, so 2, cross out, 3, cross out, times 3. Notice I'm multiplying in between. Multiplying prime numbers of the radicand. Okay, so we did that. We did the factor tree and we wrote out our factors. What did I tell you yesterday? Was if there's no root here, what do we assume is there? 2. That's our root. So then I'm writing this down, and so are you on your homework. What's the root? It's 2. There's nothing there, so we're going to assume it's 2. So what we do is find all groups of 2. Okay? That's what we're doing up here. So the root is 2. So we're going to find all groups of 2 over here. Do you see a group of 2? Yes, right here. This is our group of 2. So watch what I do. You can pause this and then move slowly forward. You're going to take that group of 2 and you're going to put it on the outside of the radical sign, and whatever is left over goes on the inside. So whatever is left over goes on the inside, and that's your answer. I would strongly suggest you rewind that example, watch it again, or I can just explain it one more time. We have to simplify this. This is not a perfect square. So we do our prime factorization. We write it out least to greatest. We're multiplying, by the way. We look at the root. The root tells us everything. The root is 2 because there's nothing there. So then we look over here, find all the groups of 2. Here's one right here. We only take one of those out and it goes on the outside of the radical sign. Whatever's left over goes on the inside. See that? That's how you solve it. Okay. Because basically what this is saying, what is 3 times 3? It's 9. Look at this. 3 times 3 is 9 times 2. Is that a perfect square? Yeah, that's 3 times square root of 2. That's how you read it. 3 times square root of 2. Okay, if this is still confusing, which I think with this class it may be a little confusing, especially with me being here. If this part right here makes sense, and that's all that matters right now, right? Okay. Let's do another one. See, I'm afraid if I explain it in great detail, your parents that are watching may understand it, and some of you may too, but some of you that might actually confuse you more. Hey, let's do another example. All right, let's simplify the square root of 24. All right, there is no number that times itself gives us 24. 5 times 5 is 25, but there is nothing that times itself gives us 24. So I'm going to do a factor tree. We can do, and you know you can do any two numbers. I'm going to choose 6 times 4. And then I'm going to choose 2 times 3, circle my prime, and then 2 times 2, circle my prime. 24, remember we write it out, least to greatest. And cross out, and you can explain to your parents why I'm crossing it out. And don't say, because I'm a neat freak. Times 3. Okay, now, question, what is the root? What's the root? We have nothing here, so what do we pretend it is? It's a 2. We have to look at that. So the root is 2. So we are, and yes, I'm writing this down each time, we're finding groups of 2. Do you see any groups of 2? Yes, you do, right here. So, and I'm going to draw an arrow. So that group of 2, you're going to take 1 2 out. It goes on the outside of the radical sign. Now these right here are your leftovers. Those are they don't have pairs, so you're putting them underneath. 2 times 3. What is 2 times 3? 6. So there's your answer. See, that's not so bad. I really think today's is going to be a little bit easier than what y'all did yesterday. So again, to recap, there's what you have to simplify. Did a factor tree. You know how to do that. List them least to greatest. You have to determine the root because it's going to change, believe it or not. I'm doing a lot of 2's, but it's going to change. The root is 2, so you're finding groups of 2. You circle that group and you only take 1 out. Remember, this is kind of like the greatest common factor and least common multiple things we did, okay? So we find a group of 2, take 1 of those out. Whatever you have left over goes underneath. Remember, we're multiplying. So 2 times 3 is 6. Okay, let's do another. $45. If y'all want to, you can pause right now, work it out, and see if you get it correctly. Because I think by now it may be, some of you may be catching on. If you want to do another example and then pause later, that's fine too. First thing we do is factor tree. 9 times 5. 5 is prime, so we circle it. 3 times 3. 3 is prime and 3 is prime. So I'm going to write 45, and it's 3, cross out, times 3, cross out, times 5, cross out. All right, children, what is the root Well, the root is 2 because there's nothing there. There's nothing there, so the root is 2. So we're finding groups of what? Finding groups of 2. And I have a group of 2 right here. That becomes a 3 on the outside of the radical side. Whoops, I'm so sorry. And then this that's left over goes on the inside. And there's only a 5 left over, so you're done. See, this isn't so bad. If you need to rewind it, or if you're completely lost and you're getting annoyed because I keep saying this isn't as bad as yesterday, then just ignore me, go back over it, and you can contact me anytime that you have questions. But make sure you watch this video, even if you have to watch it 2 or 3 times before you jump on the phone and call me. All right, 288. All right, y'all can try pausing it, seeing if you get the right answer. This one's going to be weird, though, just a warning. All right, so let's do the factor tree. Okay, so I've already worked this out with my class last year. So I'm going to choose 144 times 2. 2 is prime. 12 times 12. 3 times 4. Circle your primes. And then I have 2 times 2. Okay, sorry, my phone is blowing up. Okay, now we write out our prime factors. I have, well, we can start here. 2, cross out. Now you see why we cross it out, parents, because we have so many here, we want to make sure we get all of them. Times 2, times 2, times 2, because even their teacher gets confused. Times 3, times 3. Okay, what is my root? Okay, there's nothing there, so we assume it's a 2. So we're looking for groups of 2. Groups of 2. So I have 1 here, here, and I have here. Oh my, this is a little bit different. I have a lot of groups. So all of these are going to go on the outside. Notice I'm taking 1 of each, and since we're multiplying everything, I'm multiplying out here as well. That's on the outside. This 2 is what's left over. It's going to go on the inside. 2 times 2 is 4. 4 times 3 is 12. There you go. So remember, all the groups of whatever the root is go on the outside, and you multiply them. And then whatever's left over is on the inside. If I had more than a 2 left over, like if I had another 3, it would go under here and it would be multiplied just like we did right here. See the leftovers? Okay. Let's do another example. Oh boy, look at that. A little bit different. All right, let's do our factor tree. We can do 5 times 27. Circle our prime. 9 times 3. Circle our prime. And 3 times 3. Circle our prime. So then 135. I have 3 times 3 times 3 times 5. Okay? What is my root? What's my root, guys? It's right here. It's 3. So now we're finding groups of 3, not 2 this time. So here's a group of 3 right here. That's going to go on the outside. And this 5 goes on the inside. Now, there's one more important thing. Remember that root, that's a 3? You must include that root right there. You must. Very important. That root needs to go right there. Do not forget that. Okay. So there is what you would do if you had a root of 3. You just circle groups of 3. That's it. Same thing as all the others. So I think some of you probably are getting it. If you still are having questions, you let me know. Okay. So examples. Since we've done so many examples of roots of 2 and everything, I think you've got it. I'm going to do 2 examples of using variables. All right, so watch this. This is not bad. Don't worry. 50x cubed y cubed. Okay? All right, now remember, because y'all have done this too, when we do the factor tree, we're just going to do the number. 25 times 2, circle your prime number, and then 5 times 5. So then I have 50 times 2 times 5 times 5. But I also have 3 x's. In fact, I could even write that over here. So times x times x times x. Remember this, guys? That's right. You had a test over it recently. And then 3 y's. What is my root? There's nothing there, so it's 2. So this time I'm looking for groups of 2. All right, so here's a group of 2. I have 3 x's, so I can circle one group of x's, and I have 3 y's. Circle another group. Remember, there's 3 x's and 3 y's, so I write them out like this with the multiplication in between. And they go on the outside. 5 times x times y goes on the outside, times your square root of what do you have left over? You have a 2, an x, and a y left over. So 2 times x times y. You put the leftovers on the inside. Notice we're doing all multiplication. All the groups go on the outside. So what's 5 times x times y? 5xy times the square root of what's 2 times x times y? 2xy. There's your answer. And that's a root of 2, so we can just leave that blank. Okay, one more. 29. Again, either rewind this and watch again, or try to do this on your own if you got it. 75 a cubed b c to the 8th power. Okay, so I'm going to come over. Ooh, that's going to be long. That's a lot of C's there. Okay, so I have 75, A, Q, B, C, 8. Okay, we got to do our factor tree. 5 times 15, circle your prime. 3 times 5, circle our primes. So I have 75, and it's 3, cross it out, times 5, cross it out, times 5, cross it out. We have 3 A's times A times A times A times 1 B, and then times 8 C's. I'm going to do it down here. 1, 2, 3, 4, 5, 6, 7, 8. What is my root? It's 2, because there's nothing here. So I'm going to go circle all of my groups of 2. Here's 1. Here's 1. Look at all these. Okay, remember, all of the stuff that's circled goes on the outside. So I have 5 times A. If you want, you can cross that out. And I have 4 C's. 4 C's. 4 groups of C's. 1, 2, 3, 4. Times the square root of whatever is left over. 3, A, and B. 3 times A times B. Now, 5 times A times C to the 4th power is 5AC to the 4th power times square root of 3AB. If you need to rewind this, go ahead and look at it again. If you have questions, and I'm serious, you need to take it upon yourself to rewind this if you're confused. And then pause it, watch it, and pause it after each step so that you really analyze each step. Okay? All right, you're going to be doing page 439. Okay, you're going to be doing 2 through 16 even and 18, 26, and 32. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Think you can handle 11 problems. Now, some of these may say cannot be simplified. Okay, some of them may, say that. In fact, I'll go ahead and tell you there's only one. Only one of this group cannot be simplified. You've got to figure out which one that is. Only one. Yep, I'm looking. Only one. Okay? All right, this is going to be due Wednesday. As of right now, you still have a quiz Monday, and IXL is due Monday. Okay, guys? All right. Again, rewind the video and see if you have any questions. All right? Bye. Miss y'all.